Okay, so today we're going to start Chapter 9. We're only going to be doing a few sections in Chapter 9. They all deal with rational expressions. So our warm-up today is just a review of factoring back from Chapter 5. So remember, when the a value is not 1, you will have to do guess and check. So the only numbers that would multiply to get us 2x squared would be 2x and x. And the only numbers that multiply to 1 would be 1 and 1, or negative 1 and negative 1. So knowing that we want this to FOIL back to get negative 3, they both must be negative. And you can check by FOILing that to see that we both get negative 3x. This one is a special case. This is our difference of squares. So remember, when you have a perfect square in the front and the back, we'll have one positive and one negative. That way, when we FOIL, we'll get 0x in the middle. And number 3, we also have a guess and check, although the numbers are pretty simple. This should be 5x and 1x. And the only numbers that multiply to 1 are 1 and 1. All right, so what we're going to be doing today is just reviewing simplifying rational expressions, which is actually something we did do in Chapter 5, but I figured since it's been a while we would review. So remember, simplest form is when the numerator and the denominator are polynomials with no common factors. So basically, it just means that it can't be simplified any further. So we have examples down here. These are in simplest form. These cannot be simplified anymore because remember, the quantity x minus 1 is a binomial. Same thing here. We have a binomial, so nothing can be reduced. Now, these examples are not in simplest form. Okay, this one we could reduce because we have a common factor of x in the top and the bottom. So this would reduce to be 1 over x. This one we're going to look at later, which is called a complex fraction. So I won't teach you how to solve that yet, but this one we could divide out the common binomials and get 2/3. So those would not be in simplest form because they could be simplified further. So remember, your steps for simplifying are to factor the numerator, factor the denominator, divide out any common factors, and we also will state restrictions on the variables, which means the original denominator before canceling anything out cannot be 0. So for number 1, we see a quadratic over a quadratic. You cannot, I repeat, cannot cross off the x squareds. These are polynomials that are grouped, imaginary parentheses. So we will factor the top into x plus 5 and x plus 5. And we'll factor the denominator into numbers that multiply to 20 and add to 9 would be 5 and 4. So we can cancel out one pair, or divide out one pair of our binomials that match. So we're left with x plus 5 divided by x plus 4. You cannot cancel out the x's. This is our answer. Our restrictions are that the denominator, the original denominator, cannot be 0. So we would have x plus 5 cannot equal 0, which would tell me x cannot equal negative 5. And the other one, we would subtract 4 to get that it also cannot equal negative 4. So we have 2 restrictions. Even though these were divided out, you have to look at your original before clearing those. So those are our 2 restrictions. Okay, now the next one, we do not have any binomials. We don't have to put parentheses. These are monomials. So we can actually just divide the numbers. Negative 27 divided by 9 is negative 3 over 1. And we can use our rules for exponents. Subtracting 3 minus 4 will get me negative 1, which then moves to the denominator. So we have x to the first down here. And the y's will just divide out. So we'll have negative 3 over x. Then we need to have our restrictions. So looking at my original denominator, I will just say that x can't be 0 and y can't be 0. All right, now the next one, we can factor the numerator. We could take out a 3 or a negative 3. I'd probably take out a negative 3 since there's a negative in the front. That will get me 2 plus x, or x plus 2. In the denominator, numbers that multiply to 8 and add to negative 6 will be negative 4 and negative 2. So I put this one on here just so you realize that not always will you have something that simplifies out. We cannot cross these off because one's a plus and one's a minus. So this is actually not able to be simplified. So we can leave our answer like this, and we can state our restrictions, which would be that x minus 4 can't be 0, therefore x cannot equal 4. And I'll just put a comma and list my other number, which is 2. Because 4 minus 4 is 0, and 2 minus 2 would get me 0. Okay, last two, same thing. You're just factoring and dividing out common factors. Remember, you can also take out a GCF sometimes, so always look for that first. Our top one, we have to do a little bit of guess and checking. This will be 2x and x because of this. The other two numbers are 2 and 1, so we have to figure out where to put the 1 and the 2. So when we FOIL back, we get negative 3. So I'm going to make this a negative 2 over here so that when I multiply, I get negative 4. And then plus 1, which will get me a negative 3. In the denominator, this is an easy factoring. Factors of 6 that add to negative 5 would be a negative 3 and a negative 2. We can divide out our common binomials, and we're done. We just have to state restrictions. So x would not be able to be 3 or 2. Basically just taking the opposite of those. Try the last one on your own. We should get x minus 8 divided by x plus 3. The restrictions are negative 2 and negative 3. All right, on the back we just have actually some geometry relationships here. We're looking at designing a structure where we want to maximize the volume or the space for working for a given surface area, material needed for construction. We want to compare the ratio, which remember the ratio is just a fraction, like A over B, of the volume to the surface area. So we're going to do the ratio of the volume over the surface area of a cylinder. And I've given you the formulas, but those of you in geometry are familiar with those. We're going to do it with a radius of r and a height of r of a cylinder, and also with a radius of r and a height of 2r. We're going to compare them. So here's our formulas. The volume and our surface area. So first write your ratio, volume over surface area. And we'll use our formulas, pi r squared all over our surface area, which is 2 pi rh plus 2 pi r squared. And then we have like two columns here. In this column, we're going to let the height be the same as the radius. So I'm just going to take r and plug it in for h. So I will simplify that now. The numerator, I'll also plug it in here. So in the numerator, r squared times r is r cubed. In the denominator, I'll have 2 pi, r times r is r squared, plus another 2 pi r squared. So the numerator we'll leave alone. In the denominator, you can actually add these because they have like terms. 2 pi r squared plus 2 pi r squared would be 4 pi r squared. And then we're going to simplify that. So the pi's will divide out. We can use our rules of exponents here. 3 minus 2 will get me 1, a positive 1, so it'll stay up top. So I will get r divided by 4. So the ratio would be the radius is just being divided by 4. Now for the cylinder, with a height of 2r, so we're looking at twice the radius as being the height, we're going to use the same formula, same ratio. But this time we're going to plug 2r in for each. And we'll simplify that. This will get me 2 pi r cubed. In the denominator, I will have 2 times 2 is 4. Pi, r times r is r squared. Plus, and this will just stay the same, 2 pi r squared. In the denominator, we can again combine our like terms, since they both have the same exponent and the same variable. 4 pi plus 2 pi will get us 6 pi r squared. Again, our pi's will divide out. We can simplify 2/6 to be 1/3, and our r's, 3 minus 2, gets me r to the first. Then they ask us to find the volume to surface area of a cylinder whose height is 4r. So we're just going to take that same formula and plug in that the height equals 4r. So pi r squared h, which I'm just going to go ahead and plug in 4r there, using this formula up here. 2 pi r h, which we're plugging in 4r, plus 2 pi r squared. And we're going to notice a relationship between these answers. So on the top we'll get 4 pi r cubed. And the bottom, when I simplify this, I'm going to get 8 pi r squared plus 2 pi r squared, which will get me 10 pi r squared. The pi's will divide out. We can reduce the 4/10 to be 2/5, and again this will be r. So 2r divided by 5. All right, for part C, they say let mr be the height of a cylinder with radius r and m be a positive number. Describe how the ratio of the volume to the surface area changes as m changes. So I'm actually going to go ahead and just get rid of this part, and let's just compare the ratio as m got bigger, because we already did this. In this case, m was 1. In this case, m was 2. In this case, m was 4. So as m got larger, what do we notice happened? Now, some of you will say that the denominators changed or the numerators stayed the same except this one. But you kind of want to think of this as being 1/4 r, 1/3 r, and 2/5 r. And think about those values. This would be 0.25 r. This would be 0.3 repeating r. And this would be 0.4 r. So you'll notice that as m gets larger, the ratio itself is also getting larger, because 0.3 is bigger than 0.25 and 0.4 is bigger than 0.3. So we will say as m gets larger, the ratio also gets larger. And then your homework assignment, we are skipping 7, I don't think it's on your note sheet, is on Google Classroom, 9.4 day 1, and you'll complete that on notebook paper. Please make sure that you show all work to receive credit.